Welcome back after the ad break. I hope you're feeling refreshed now and we can continue with the ear. So we've done the structure of the ear and now we will be looking at hearing part of the ear. So if we look at this diagram, it starts off by the sound waves. Remember I talked about sound waves? Your pinna will now be trapping these sound waves and direct them into the auditory canal. Right. So the auditory canal also directs them toward the tympanic membrane. And the tympanic membrane then starts to vibrate. Now let me just show you how that works. So if this is your tympanic membrane, and the sound wave will be coming towards it. The moment it bumps against it, it starts to vibrate in and out, right? And like I said, the vibrations is the same frequency as the sound wave, okay? But on this tympanic membrane, you have the malleus, the little hammer, is fixed on it. So the moment this tympanic membrane starts to move, this malleus will also start to move, right? And ossicles or malleus, they are the three little bones, they work like levers, right? So if say for example this is the malleus and it starts to move and this is the incus there, if it goes like this one will go like this. So they will move like this, right? That's vibrations, levers, right? They work like levers. Okay, so then the vibration will then move through these ossicles to the oval window. And the oval window will cause pressure waves within the liquid here, and that will now start to stimulate the organ of Corti, which is in there, in the cochlea, right? And what happens when a receptor cell is stimulated? It converts it to an impulse, right? It will always convert the stimulus into an impulse. What happens to that impulse? It will go via the auditory nerve, which is there, to the brain. But now we don't talk about the brain, we talk about the cerebrum. Remember when we spoke about the brain and I told you that the cerebrum will always receive impulses from your sense organs. Now your ear is a sense organ. It will interpret it and react on it. Okay, so now here you have to specify cerebrum. You can't just say brain because the examiners want to know, do you know which part of the brain? It will be the cerebrum, always with hearing. All right, let's move on. Now I tried to make it simple for you by using this little flow chart. The pinna, well, the sound will move from the pinna to the auditory canal, to the tympanic membrane, to the malleus, incus, stapes, to the oval window, to the cochlea with the organ of Corti, where it will be converted into an impulse and transmitted via the auditory nerve to the cerebrum. And I made a little mnemonic about it. So let's look, if you look at the first letter of each word, P-A-T. So it's pat, M-I-S, miss, O-C, C-A-C. Sac, right. So pat, miss, OC, sac. All right. If you can remember that mnemonic, you will be able to remember the sound of the ear, how it works in the ear. But also, just when you study the ear, just know all the structures and the functions of the ear, know what this is, know what this is. Then it's very easy just to think of your ear and how the pathway of sound works through the ear. All right, if you don't like mnemonics. Right, but let's look a little bit more in detail of how hearing works. Right, we have the oval window. Here it is. Okay, and that's the stapes there. Now this is vibrating. Vibrating meaning going in and then out again. Right, so that's the vibration. Now that causes, every time it goes in, it causes a little wave. Right, so every time it goes in, it causes this little waves going there. So that's what all this arrows are all about. So this is liquid, that's liquid, all of it's liquid. You don't need to know the liquid's names. But the moment that pressure wave is there, it is now pressing down on this membrane here, right there, and it stimulates the organ of Corti, which is situated there. There they are, right. So when it presses down on that, it is stimulated. It will then convert this stimulus Let me just get the pen again. So like I said, the organ of Corti is then stimulated here, right? And then it converts the stimulus into an impulse. Remember the word impulse, not a message, right? And that will always be transported via the auditory nerve, not any other nerve, to the cerebrum. There's the word, cerebrum, right? Now the round window's got another function, and that is the following. Here, all the pressure waves comes and it comes and it comes. If there was nothing, just a little wall there, what would happen is they would reflect. They would reflect and they would go back. So you will start getting interference now, because they will go this way and the original waves will go that way, and you will get a lot of distortion of sound, right? And it wouldn't work. You will have a very loud noise in your head, and the sound wouldn't sound clearly, right? So what this round window does, it starts to vibrate at the same frequency that the pressure waves are. So that it's releasing the energy. It's releasing it, so it doesn't reflect back. It doesn't cause any trouble in the liquid, and you can hear nicely and clearly. Oopsie. Right, now this is a very important slide. You have to know exactly what words to use in which part of the ear. Now, if you look at the pinna and the auditory canal, we talk about sound waves there, sound waves, right? Then we move to the tympanic membrane, which vibrates. The ossicles, which vibrate. The oval window, which vibrates, so it's vibrations there. In the cochlea, there's liquid. Now we talk about pressure waves, not vibrations anymore. Organ of Corti will convert it into an impulse. So here we talk about impulse, right? So you cannot talk about vibrations in the cochlea. No, then you won't get the mark. You have to talk about pressure waves in the cochlea. The same with ossicles. It's not sound waves here, it's vibrations. It's vibrations. It's vibrations. So you need to use the correct terms for the correct part of the ear, or else you will lose marks. So that's why this slide is very important to remember.